Okay, in this tutorial, we've pretty much covered most of the profile, how we enter elements and change drives and pulleys and wrap angles, import files from AutoCAD, so on and so forth. But something I really want to drive home again is just this concept of this return side element. It seems like most people find it pretty straightforward to put in each of their element lengths and enter their carry side, put in their pulleys and get all that right. But sometimes this return side element still is a bit of a problem. So I just want to just have a tutorial just focus specifically on that. So I've opened a new file. Just going to go ahead and click continue. And just let's zoom in on the head pulley here. Let's zoom 1 to 1. This conveyor has simply got a motor and the return side and then the take-up pulley. Now something that I usually actually like to do is rather than start the return side right after a motor or right after a pulley, I actually usually like to just insert a short little element coming back to the belt line or whatever it happens to be. And this is nice for a couple reasons. One, I can go ahead and match up my wrap angle. So I can give it the exact wrap angle I need. Obviously if this came out straight, then we've got a discontinuity, and that's simply for the fact that our return side by default will drop half a meter, 500 millimeters from our carry side. If that's not the case, this return side offset right here, I can go ahead and change that. The default, like I said, was a half a meter, but I can change that to 1 meter, 2 meters, half a meter again, whatever. Let's go ahead and specify our pulley diameter. We'll just say we have a 1,000 millimeter pulley diameter in this case. So in that case, obviously, if we drop down 1 meter, our return side would be directly in line. More realistic probably is closer to a half a meter, in which case we'd maybe need a snub pulley in here. So let's go ahead and bring that flight up a half a meter. And let's insert a couple more elements. We'll add a pulley. And again, as I said, I kind of like to exit with a straight element. And there's our snub pulley. Now obviously that would probably be a smaller diameter, so let's go ahead and just make that a different pulley type. We'll call that pulley type number 2. And let's maybe say that's a 500 millimeter pulley diameter. And there we have it. So again, the return side will map back from wherever the previous flight ended, i.e. from this point, and it will map all the way back to whatever value you specify as the station and elevation of the next flight. In this case, it's mapping back to 0, 0 and 0.8. Now if we zoom in on that, well, we specified pulley 2 is a half a meter pulley, so we can see we're actually off by a half a meter. We're mapping back to 0.8 and this is 0.3. Now I can correct that by actually just entering negative 0.5 here, or I can do a little trick and just enter 0 here and that'll automatically change that. Now I could have mapped this back to any point. I could have mapped back to say 5 and minus 1 meter, at which point I could now insert and go ahead and enter some more elements. Maybe I make an element that's minus 4 meters and I add a pulley or do whatever I want. The point is after the return, whatever numbers I enter here is where that flight is going to map back to. I'm going to go ahead and we're going to do something here. I'm going to delete this. So all we have is a return station. And where this sort of confuses people is when you have a massive pulley arrangement. Maybe you've got a turnover station or multiple pulleys or whatever at the tail pulley. Then this gets a little more confusing. So we're just going to go through that manually right now. So I'm on this last element. I'm going to say insert a layout at the tail. And let's just choose a dual drive with a horizontal take-up. So I go ahead and click that. And we can see if we pan over here, we've just inserted a minus 7 meter flight, some pulleys, a take-up, and a couple drives. There we go. Just inserted that. We can see that obviously our motor ends at minus 10 and 0.2, and we really wanted it to end at obviously 0, 0. So we come back to our return here, and rather than coming back to 1.25, we really needed to come back to, say, about 10 or maybe even 12 meters or so. And vertically we're about right. Just going to zoom out a little bit here. There we go. Now, a trick, rather than having to know or just keep playing with this 12, 10, 14 until we get it right, a little trick is this adjust to end button. And this is pretty handy. Normally what this does, if you're on any flight, if you're at any flight along the conveyor and I click this adjust to end, it will adjust the length and the height of that flight such that the very last point comes back to 0, 0. The only exception to that rule is if you're right after the return. If you're at the element after the return, it will, in that case, adjust to end, will automatically adjust the station and the elevation such that you go back to 0, 0. So you can see in this case, I'm going to go right here, I'm going to click adjust to end, and boom, it just automatically entered our return side. It said, hey, we got to go back to 11.86 and minus 1.23, which puts us dead on 0, 0 at the end. So the adjust to end button is pretty handy. Again, you use it just at the next flight after your return. Another time you could use it is, say you were coming back to this flight, and I mean we happen to have -3 and minus 0.2, but say you didn't know what that was. Maybe you were at 0.7 or something, and you didn't know what length this should be. If I click to adjust to end at this point, it'll simply again change the length of this flight, the length and the height, such that the pulley goes right back to 0, 0. So it's just sort of a shortcut. But it's very handy when you enter your whole return station. You can just go up to that flight. It's got to actually be a flight of some length, and hit adjust to end, and it'll automatically zero that out. So that's pretty handy. Just to do one more, just since we're on the track here, I'm going to go ahead and just delete all these elements. And let's go ahead and put in let's insert a layout, and again at the tail, let's just put in a simple turnover. Okay, so again, I'm going to pan over here. We come in, we've got some pulleys. Looks like we still need to add a tail pulley, so I'm going to insert just a couple more flights, a couple more elements. We're going to go maybe -5. We'll add a tail pulley, and there we go. Just to zoom out there. Maybe our tail pulley is also a type 2. Maybe these bend pulleys are type 3s. Let's go ahead and specify their diameter as maybe 400 millimeters. There we go. So there again, we've got this flight here. If I go up to this flight, rather than having to figure out exactly what numbers I need to put in there so that this ends up at 0, 0, I can just go to this flight right after the return, hit adjust to end, and whammo, it automatically has adjusted my return flight to 39.57 and -0.5, so everything's nice. And again, the big advantage of us being able to use this return side, this return element, is simply the fact that now on our carry side, when we change our carry side, we don't have to change both our carry and our return side. We just have to deal with our carry side. In other words, if I divide the carry side into, say, 6 flights, and I make this flight I don't know, go up 5 meters, and this flight go down -12 meters, and so on and so forth. You can see the return side is just automatically creating and mapping itself perfectly back so that we end up at 0, 0. Well, that's really all there is to it. As I said, it takes a little bit of playing around and getting used to, but once you get used to it, you'll find it to be a very powerful and useful feature. Again, now I could go up here and add my radius, put on a radius there of 350 or whatever it happens to be. And if I look at my conveyor profile, here are all my individual elements where I'm going to do the belt tension calculations along. On each one of these elements, we're going to calculate what the tension is at the beginning and the end of the element. So I think that wraps it up for our profile and wraps it up for this tutorial.